Hello everyone. So in this video I am going to explain about data ingestion pipeline. So first let's understand what is the meaning of data ingestion pipeline. Data ingestion pipeline means extract data from different source, then clean, transform, integrate based on requirement and load the data into data warehouse. So just assume today we received data from multiple source, we cleaned, transformed, integrated and load the data into data warehouse. Next day again we have to follow same process, so we have to continue same process every day. So in that case what we can do, we can create a one pipeline. In the pipeline what will happen, data will flow and it and every step there will be some transformation to clean the data, to transform the data, to integrate the data. And in that pipeline we will schedule on daily or hourly or monthly based on our requirement, and then accordingly data will be stored in our storage, either in data warehouse or in data lakes. So in Azure data service we have a two type of we have multiple pipeline, but in this I am going to discuss two pipeline. One is Azure Data Factory and Azure Synapse Analytics. So how to work on Azure Data Factory, how to work on Synapse Analytics, how to create these services, everything will be discussed in data engineering class. So here I am just giving intro of data ingestion pipeline. So after ingesting the data and transforming the data, we have to store data. So we can store data at two places, means either in data warehouse or in data lake. So let's see one by one. Data warehouse is a relational database in which the data is stored in a schema that is optimized for data analytics rather than transactional workload. Means optimized for data analytics. It means it should be optimized to keep historical data, 4-year, 5-year, 10-year data. Commonly, the data from transactional store is transformed into a schema in which numeric value are stored in central fact table, which are related to one or more dimensional table that represent entity by which data can be aggregated. Let's understand with the example. So we have a retail data. So in the retail data, we have a sales data like transaction data, and same time we have a product information, customer information. So this kind of descriptive data we do store in dimension table called dim product, called dim dimension. And transaction data we can store. Transaction data means numerical data, so we do store this data in fact table. So this kind of fact and dimension table schema is called star schema, and we can extend this schema into snowflake schema by adding some additional table related to dimension table. Just example, dimension hierarchy means product, dim product, then dim product category, like that. Now let's see data lake. Data lake is a file store usually on distributed file system for high performance data access. Technology like Spark or Hadoop are often used to process query on stored file and return data for reporting and analytics. So in data lake what we do store data in a file system. This system often apply a schema on read approach to define tabular schema or semi-structured data file at the point where data is read for analysis. Means data is stored in file, but to get the data in required format we can define table schema. So how to define a schema, everything I will show in Synapse class. In that class I will show you like how my data is stored in data lakes, and then I am creating a schema on that data and then fetching, and while fetching it will look same as table type. Like we will feel like we are fetching data from table, but actually we will be fetching data from file. Data lake are great for supporting a mix of structured, semi-structured and even unstructured data that we want to analyze without the need for schema enforcement when the data is written to the store. Means in a data lake we can store structured, semi-structured, even unstructured data, but in data warehouse we do store only structured data. So this is all about data ingestion pipeline, means how to like extract data, transform data, clean data, integrate data, then load the data into data warehouse. This is just theoretical part. So soon I am going to start Azure data engineering class where I will show everything practically. Thank you.